5, solve special types of linear systems. So these ones, well, let me check. Typically, they say to like either use substitution or elimination. So you'll be able to choose which method you want. It looked like pretty much on the one on the quiz that y'all got to choose that most of you chose elimination. A couple chose substitution, which that one would totally work either way. I mean, they all do, but that one really didn't make a difference one way or the other. So the other day, you might remember briefly that I mentioned, let me see what section it was in that I talked about it. I said there was like a name for the type of solution. Anybody remember what that name was?
No.
Trying to remember what section it is. It might have been all the way back in 7.1. Yes, it was. Okay. It was called, so this was all the way back from 7.1. It was called a consistent, independent system, which means that we have one solution. So all the problems that we have done to this point have had one solution, right? Written as an ordered pair. So now we're going to have some other options. We can have the consistent, independent, that's still an option. We can also have consistent and dependent system, which means that it has infinitely many solutions. So this would be if you're solving it out. Well, I'll show you with a graph in a minute what they look like, because we'll have some where we're graphing. But basically, when you're solving, you would get to something like 0 equals 0, -2 equals -2. Like, there won't be variables left. It'll just be, like, numbers, essentially. All the variables are going to cancel and whatnot. So the way that I keep track of consistent and independent or consistent and dependent is if you're independent, you do things by yourself. So it's just one of you, right? If you're dependent, you depend on something else. And so that means there's like multiple like things that play into that. So infinitely many would be the consistent and dependent one. We have one other option, and it is called inconsistent. It's just an inconsistent system. And this means that there is no solution. So with that one, we would get something like 0 equals -7. Well, is that ever true? No. So essentially, inconsistent, which is no solution, produces a false statement. So when we answer these things, if it's infinitely many solutions, you will write infinitely many solutions, and then you will say if it's consistent and dependent, which in that case it would be. If there's no solution, you would write that it's inconsistent. So you have to have both of these things that I have written. So like these things, they go together. So if you say it's infinitely many, you also say it's consistent and dependent. If it's no solution, you also say that it's inconsistent. Does that make sense? Okay. And if it asks you to, so I took it off on the quiz that you had yesterday because obviously the only option was consistent and independent. But originally on the quiz, I actually had on there to say if it was, like, what kind it was. And then I was like, well, until we learn the special types, it doesn't make sense. So probably on the test, what you will see is some of the questions will tell you to label them as consistent and independent, consistent and dependent, or inconsistent. So if it's one solution, it's always that top one up here. Okay? But you don't have to put that unless it asks for it. So just make sure you're aware and watching for that. So we can still use graphing to do this. We can use substitution, elimination. It doesn't matter. As far as determining number of solutions, very chatty. What are they doing? All right, so determining number of solutions, if we have, I'm going to do a little table here so that you can see this. So I'm trying to give you just some different ways to kind of think about the same stuff. This will be number of solution and then what you'll know about their, I can't write, slopes and y-intercept. So if it's one solution, then they have to have different slopes. Okay, they don't have to be anything special, they just have to be different. If it is no solution, then what we have is we have the same slope, different y-intercepts. Okay, so in this case, these would actually be parallel lines if you're looking at the graph. Then your last one is infinitely many solutions. Which is the same slope in the same y-intercept. So basically these come out to be the exact same line. So it's just like a line on top of a line. So I'll draw you a little picture of what these kind of look like here. So one solution. Oh, here, I'm going to go ahead and label these all out. No solution and infinitely many. All right, so one solution, obviously that's what we've been doing. The graph would look something like that. Obviously they could intersect a different way. Anywhere that they're just intersecting one time is one solution. No solution, we've got parallel lines that aren't intersecting at all. And then infinitely many would just be, and obviously it can be positive, negative slope, whatever, but it's just a repeated line. So basically you're given two equations, but they both graph the exact same line. Any questions about that before we jump into some examples? History looks a lot like nap time over there, Joey. So you're laying back. Are you doing your work? Okay, well, don't be talking about basketball. Y'all doing a lot of talking if you're watching video.
Still.
All right, these first ones want us to graph the linear system, and then it says then use the graph to tell whether the linear system has one solution, no solution, or infinitely many solutions. So I'm going to put up the graph lines for these few problems. So if you want graph paper, you can. It's not as big of a deal with these problems, just because we're not actually looking for the point where they intersect. We're just telling how many solutions they have. So if you don't want to get out graph paper, that's totally fine. So number 8 is x plus y equals -2, and y equals -x plus 5. All right, so the second line is already in slope-intercept form. What do I need to do to get the top one in slope-intercept form? Subtract x, so this would give me y equals -x minus 2, and then we have this one, y equals -x plus 5. So what do we know about these slopes?
They're the same. Slopes are the same.
Yep, they're both exactly the same. Okay, so just in general, what does that mean?
No solution.
No solution. Okay, but they want us to graph these ones. So we're going to graph them because we can use the practice. All right, so the top equation, we have an intercept at -2, so that means down here I put a point. My slope is -1, so I can go down 1, right 1, or I can go up 1, back 1, however I want to do it, and then just connect there. Then the other line, I have an intercept at 5. So that's up here. And it has that same slope of -1, so I can go down 1, right 1. If I want, I can go up and back, however I want to do it. And connect it. And I've got parallel lines that are not going to intersect. Any questions on that one? All right. 10. 3x minus y equals -9, and 3x plus 5y equals -15. All right, so I need to rewrite this first line to get y by itself. How do I do that?
Subtract the 3x.
So I've got -y equals -3x minus 9. Now what? Divide by the negative. So y equals 3x plus 9. So that's going to be one line. And then over here on this one, how do I do it? Subtract 3x, so 5y equals -3x minus 15, and then what? Divide by 5. So y equals -3/5 x minus 3. So, what do we know about this one?
Well, it's not infinite analyzed solutions because everything's different.
It's not what that means. Not what that means.
Oh, yeah.
Infinitely many solutions has the same slope and the same y-intercept. They are the exact same line. So what is this situation? One solution. They have different slopes. All right, so graphing this, just so I don't have a ridiculously large graph, I'm probably going to count by 3s on the y. On the x-axis, though, I'm still just going to count by ones because, anyways, I don't need to label all of them, but just those few. Actually going to have to go over farther than that, though. Okay, so first line up here, I have an intercept of 9, so that's here. It has a slope of 3, so that means I go up 3, right 1. Or down 3, back 1. So remember, on the x-axis, I'm counting by 1s. On the y, I'm counting by 3s. Then I'll go ahead and draw that line there. Now this other line, I have an intercept at -3, so it's down here. And then I have a slope of -3/5. That means I go down 3, right 5. So down 3, so I count it, remember, increments of 3 here, and then right 5. So that's all the way over here. Or I can go up 3, and I can go back 5, which would be here. And so clearly that's intersecting in just one spot, so one solution. All right, one more graphing, and then we'll go to actually just like solving them by either substitution or elimination, because honestly that's easier than just with graphing. So 12, -9x plus 6y equals 18, and 6x minus 4y equals -12. So what do I need to do to get y by itself in the top one? Add 9x. So I have 6y equals 9x plus 18. Now what?
Divide by 6.
So y equals 9/6x plus 18 divided by 6 is 3. The 9/6 reduces to what?
1 1/3.
No. 2, 1/2.
3 1.
3/2.
3/2.
That's the.
All right, so that's the first line. How do I get y by itself in this one?
Subtract
X.
-4y equals -6x minus 12. Now what?
Divide by -4.
So y equals -6/-4x, and then plus 3. What's -6 divided by -4?
3/2.
Yep. So what do you notice about these lines?
Same slope.
Same everything.
Same everything. Yes, it's the exact same line. What does that mean?
No solution.
Infinite.
Oh yeah. I wrote the notes.
I hope y'all wrote this table down, because y'all are going to be real confused if
Can
you
I put the
didn't.
infinite sign, or do I have to write infinite like every single time?
You have to write it.
Damn, you have to write it too.
I do, but I already do.
Is it readable?
What do you mean I did it?
The voice cry.
All right, so if I graphed this, if you had to graph this particular problem, it's only going to end up with one line on it. All right, so I have an intercept of 3, a slope of 3/2. So up 3, right 2, or down 3, back 2. I almost had it through the long point. It's close enough. So there's just one line because those are the exact same line. All right, moving into the problems where we're actually solving them. Or well, first, are there any questions about these ones that we're graphing? All right. So make sure you pay attention if it's just wanting you to graph it and tell if it has one solution, no solution, or infinitely many, or if it's actually asking you to solve the system. So these ones are saying to solve. So I've got -16x plus 2y equals -2, and I've got y equals 8x minus 1. All right, so I can either use substitution or elimination. Which method do you think I should use on this one?
Substitution.
Substitution, why?
Because I don't want to do all that math.
Because the y's already by itself, and Grace doesn't want to do all the math.
Ray doesn't want to do math anyways.
All right, so I'm going to take this, and I'm plugging it in for this y up here. So negative 16x plus 2 times 8x minus 1 equals negative 2. So I distribute here. So negative 16x plus 16x minus 2 equals negative 2. What happens?
0.
What?
Huh?
What?
What happens? Negative 16x and positive 16x, what happens?
Zero.
Okay, yes, they cancel. So then I end up with negative 2 equals negative 2. What is that?
-2.
That's true. That's a solution.
That's always true, right? Always and forever true. So that means infinitely many solutions. And guess what? Then you're done with that problem.
Yay!
I like those the most.
I love it.
Infinitely many and no solution are going to be your favorite.
I don't like the most.
Now, some people say that you need to get to 0 equals 0. I could still do that. I could add the 2 over and get 0 equals 0. It's going to be the same thing. If it's negative 2 equals negative 2 or 0 equals 0,
It's
the exact same thing. It doesn't matter. So I'm just letting you know, in case you decided to move the 2 over, you'd still get 0 equals 0. It's going to still be add 2.
Where you get the 2?
I add 2 to both sides, and I get 0 equals 0.
How do you get the +2 then?
How do you move something from the left to the right?
Give him a second. Let him explain.
No.
All right, 18. 5x minus 5y equals negative 3, and y equals x plus 0.06.
Guys, I think substitution.
No.
I'm gonna go substitution. Grace, you don't want to do substitution? Oh, she doesn't like decimals. She doesn't like decimals. That's it.
Decimals are easy.
All right,
Fractions are.
we are going to do substitution, and yes, this one obviously does have a decimal in it, but we're going to do it so we can review multiplying decimals, because I feel like sometimes we struggle with that. So 5x minus 5 times x plus 0.06 equals negative 3. So I've got 5x, and then distribute minus 5x. Okay, I don't know what 0.06 times 5 is, so I'm going to come over here and I'm going to multiply it. So 5 times 6 is 30. 5 times 0 is 0 plus 3 is 3. I move the decimal place 2. So it's going to be 0.3, so plus 0.3.
Wait, isn't it?
Okay, wait, minus.
Cookie for me.
Hey!
What? Yes, it is minus.
Yay!
Don't worry, guys. You know how to help out.
Sam, be quiet.
Is there a typo in this book? Book has a typo. And yes, I will give you a cookie point in just a second. Alright, so 5x minus 5x is, so then I have negative 0.3 equals negative 3.
Guys, I don't
They
think
are
that's
not
true.
the same.
I don't think that's true.
That's not. I think
So what does that mean?
No solution.
No solution.
I think one of them has a decimal.
Hey, I also like honestly.
There's definitely a typo in the book because they said it's infinitely many, and those are not the same thing.
What?
So they either meant to put that this was negative 0.3, or they have the wrong final answer. One of the two. Anyways, the answer is wrong.
We have more than pre-cal and algebra.
We're better than the book.
I'm pretty sure pre-cal just doesn't care.
Pre-cal just doesn't care.
Why would they not want
They just don't talk. I can barely get them to answer a question when I ask them, like, what's 3 plus 3? Like, they sit there and they all look at me, and I'm like,
Hey.
anybody
Like,
want to tell me what the answer is? Like,
That would be the classroom of Sam
Don't do it
and
forever
Ovidio.
at the same time.
That would be the classroom of Sam, Ovidio, and Grace all.
Bruh.
Yeah,
it's very
yeah.
annoying.
I've been answering this whole entire time, dude.
No, you just be going, yeah, I got it right. So you're gonna do it. Oh, so now you're like saying whatever you
We still
right.
did.
Oh,
I wonder
I
I forgot I had 10.
Oh, video.
I didn't think the test went.
Just a correction, I
It's a
have the
quiz.
problem written wrong, that's why
Oh,
it's,
it got that one.
anyways, that's why it's, their answer is wrong.
No,
Anyways.
man.
This is the answer to our problem, is no solution.
You didn't say no.
Alright, 20.
No, it gotta be.
Trying to get the.
X minus 2y equals 7, and negative x plus 2y equals 7. What method should I use here?
Elimination.
Elimination, because I have things that are opposite signs and the same number. What happens on the left?
You get 0.
You had 0 equals, and what is that?
I don't think that's true.
That's
That's
not
no
true.
solution.
No solution.
Oh, but you can't just come in and answer our question.
I don't know, guys.
John, give me a 2-second briefing on what just happened.
Graphing
graphic.
and then not graphing.
Okay, got you. I know
Yeah,
it.
you missed the graph.
Alright, so to get the full credit for this problem, okay, you have to show that 0 equals 14, and then you have to say no solution. Okay? Let's see, 22. 4y plus 5x equals 15, and x equals 8y plus 3.
Guys, I think we're gonna do a bit of substitution.
Grace loves substitution.
I think I fully agree with John.
Alright, so substitution, I'm going to plug this stuff in for x up here. So 4y plus 5 times 8y plus 3 equals 15. So 4y plus 40y plus 15 equals 15. So combine like terms, 44y equals, and I'm going to subtract this 15 over 0. So what is y?
0.
0.
So y equals 0. Now I take this and I plug it into this equation. So x equals 8 times 0 plus 3. So x equals.
3.
Now, how do I write my answer?
3, 0.
Yes, as an ordered pair. Some of you did not do any of your ordered pairs on the quiz.
I did some.
Do that?
Wait,
just blocks the answer.
No,
No, you
it's
gotta
supposed to be
do
an
it.
ordered pair.
God, do it.
I'm gonna you. Is this your English work? Shut up.
Where-
I thought you were block y equals.
All right, any questions on those ones so far?
No.
All right, the next ones want us to solve the system, but when we're done, we also need to say on top of if it is one solution or what? Without solving the linear system. Oh,
Stop it, Alana.
just kidding. Are they really not going to have us do that? I guess they're not going to have us do that. Okay, well, disregard what I just said. These ones actually say without solving the linear system, tell whether the linear system has one solution, no solution, or infinitely many solutions.
No, you don't.
So essentially, this is what we were doing in the first thing. 26. Y equals negative 6x minus 2, and then 12x plus 2y equals negative 6. So I need to figure out without solving, so I can't use substitution. I need to figure out how many solutions these have.
Oh, 2.
2.
2 is not an option.
Y to like.
It's either none, 1, or infinitely many.
Subtract
Infinitely many.
Oh, I did not get that.
What?
So subtract 12x, so 2y equals negative 12x minus 6. What?
You said not to do the math though.
I said without solving.
Oh.
I didn't say don't do the math. I said don't solve.
She only wanted you to do the math.
Yeah, this is math.
This is math
What is
class,
happening?
Grace. So you
Mom
gotta
in
get
the
the
camp.
Uh-oh.
Let's
Uh-oh.
not hands. Imposter spotted. I think she sees Freddy.
This isn't Prom Night at Freddy's.
You said I will. Yeah, shit.
Every single thing on that board is
You do. says we do you eat it. You eat it.
I could really
Unemployed activity.
We are unemployed, dude.
No, I got a job.
He's double
I'm mopping
minor,
at
dude.
McDonald's,
Double
buddy.
minor.
I'm like you, I'm mopping at McDonald's.
Nah, you work
I'm employed, buddy.
Dude, you need to quit your job. McDonald's
All right.
is a nice pay for child, like, little kids.
Language
That's why you don't work at McDonald's.
Or
Or basketball.
Damn, Grace.
Is it no solution?
That's what I got.
Way to break the sentence.
I got no solution.
So what do I still need to do to finish this?
Divide by 2.
So y equals negative 6x. What is that? Minus 3. So what does that mean?
No solution.
Why?
Because they have different
Because
slopes. And that's the y-intercepts.
They have the same slope, and they have different y-intercepts. So that means that they are parallel lines, meaning no solution. All right, 28. 4x plus 3y equals 27, and 4x minus 3y equals negative 27.
Is that the same thing?
Do they look like they're the same thing?
Yes.
No, they're slightly different.
They might be the same numbers, but are they the same
One's
signs?
negative, one's
No.
positive, Sham.
All right, so we need to get y by itself.
You don't have
What do I need to do on this one?
Subtract 4.
Subtract 4x.
So 3y equals negative 4x plus 27. And then what?
Divide by 3.
Divide by 3.
So y equals negative 4/3 x plus 9. So now I need to do this one. What do I do?
Add 3.
Add 3y.
No, I subtract
No,
4x.
subtract 4.
Negative 3y equals negative 4x minus 27. Now what? So y equals 4/3 x plus 9.
I think we got the.
One solution.
I think we got
One
the same
solution.
thing.
One solution.
One solution. Why?
We got the
Because
They have the
Because
they have the same
it's the
everything.
same intercept.
They don't have the same anything.
They have the
They don't have the
Oh.
same anything.
negative 4.
Oh,
They have the
so-
same 9.
It's negative and this is positive. These are not the same. So that means one solution.
Why are you saying yeah, Gracie?
Yeah,
You
Gracie.
answer.
I'm a sentence.
I didn't hear you answer. I got it right.
Oh, like you did stop.
Purple, you're not even.
I'm never forget the water.
I am. Oh, the water.
All right. Any questions on this stuff?
No.
Easier than what we've been doing?
So when it says like don't like work out the problem, it's like not to use like substitution or elimination.
Yeah. All right. Problems.
Okay.
5 through 7, they're matching the graphs with the system. And then 9 through 29 odd. Now, today's Wednesday, so you should be working on this for the last 10 minutes, but they're not technically due till Friday.